Hello guys, welcome back to my channel. In this video, we'll be discussing the solutions of paper 1 of IBDP Actual Chemistry. Specifically, we would be discussing the paper of May 2021 attempt and it's of time zone 1. So let's start with the first question. In this question, they have asked us to find out which option contains the most atoms of oxygen. The main strategy here is to find which option contains the most amount of the moles of atomic oxygen. Okay, and that would give us an easy solution. So let's start with option A. So to find the moles of oxygen here, we have to find the moles of O2. To find that, firstly, we need to know the molar mass of O2, which would be 2 times 16, which would be 32 grams. Now, let's find the moles of O2. This would be given mass by molar mass. So this is 2. Then we can find the moles of oxygen. As 1 mole of O2 molecule contains 2 atoms of oxygen, so we can write it as moles of O2 would be 2 times 2, that's 4. Going on to option B, we are given the molecules of O2. To find the moles of O2, we have to divide the total number of molecules with the Avogadro number. Avogadro number is 6 times 10 to the power 23. If we cancel this out, this is 10, this is 0.2. So we have 2 moles of O2. So moles of oxygen again would be 2 times the moles of O2. So again 2 times 2, this is 4. Moving on to option C, we have 64 grams of C3H5O3. So firstly, to find the moles of C3H5O3, we need the molar mass. So molar mass of C3H5O3 would be 3 times 12 for the carbon, 5 times 1 for the hydrogen, plus 3 times 16 for the oxygen, which will come out as 89 grams. So moles of C3H5O3 would come out as 64 divided by 89. Moles of O2 would be moles of oxygen would be 3 times the total moles of C3H5O3, so 3 times 64 by 89, which would approximately come out as 2.157. Lastly, while analyzing option D, we have 1.2 times 10 to the power 24 molecules of C3H5O3. So directly moles of C3H5O3 would become 1.2 times 10 to the power 24 divided by 6 times 10 to the power 23. So it would come as 2. So moles of oxygen would be, as each molecule of C3H5O3 contains 3 atoms of oxygen, so moles of O would be 3 times the moles of C3H5O3, so 3 times 2, that's 6. So clearly from all these options, we can see the first option contains 4 moles of oxygen, second one contains 4, third one contains 2.157, and the last one contains 6. Analyzing all of them, we see that the last option contains the most amount of moles of oxygen, hence option D is the correct answer to this question. Now let's move on to the second question. In our second question, we need to find the empirical formula of the compound. We know that a sample of this compound contains 24 grams of carbon, 3 grams of hydrogen, 1.6 grams of oxygen. So to find this, it's very easy. Firstly, let's find the moles of each of these elements. So for carbon, the moles would be 24 by 12. This is 2. Moles of hydrogen would be 3 by 1. This is 3. And moles of oxygen would be 1.6 by 16. This is 0.1. Now we need to find the simplest whole number ratio between these three moles. Okay, so C is to H is to O. It is 2 is to 3 is to 1. I'm just replacing them with the moles. So to find the simplest whole number ratio, we have to just multiply all of these with 10. So 20 is to 30 is to 1. So the compound finally becomes C20H30O. So option A is our correct answer to this question. Now let's move on to the third question. This is a typical stoichiometry question. We need to find the volume of oxygen at STP. We are given that 5.8 grams of butane undergoes complete combustion. So, and they have also provided us with the balanced chemical reaction. So let's start with this question. Firstly, we need to find the molar mass of butane. Okay, so M mass of butane. This would be 4 times 12.01 plus 10 times 1.01. Now we can find the moles of butane. Moles of butane would be 5.8 divided by the molar mass of butane. I can assume the molar mass as X. So 5.8 by X, this would be the moles of butane. Okay, so X has this value. We can replace it at the end of the question. In this question, we actually don't need to do the calculations. So we can just keep it in this way. So we have the moles of butane. Now we have to write the stoichiometric ratio between butane and oxygen. So how to write the stoichiometric ratio? We need the moles of O2. And we are given the moles of C4H10. This would be equal to 13 divided by 2. 13 for oxygen, as 13 is the stoichiometric coefficient of oxygen and 2 is the stoichiometric coefficient of butane. So from here, moles of O2 would be moles of C4H10 times 13 by 2. Now, I know moles of C4H10 is 5.8 by X times 13 by 2. Now, we need to find the volume at STP. We know that any gas at STP, 1 mole of any gas at STP will contain 22.7 decimeter cube of volume. Okay, so volume of O2 is nothing but moles of O2 times 22.7. So we can just plug in the values now. 5.8 divided by 12.01 times 4 plus 1.01 times 10 times 13 by 2 times 22.7 dm cube. So this is our final answer. So if we check the options given here, option B is the correct answer to this question. Now let's move on to the next question, question number 4. So in this question, we have to find what is the relative molecular mass of bromine. Okay, molecular mass means Br2, not the atomic mass, the molecular mass. And we are given this mass spectrum. So in this mass spectrum, obviously, we can just see that this 3 bands, these will be for Br2 and this would be for atomic bromine. Okay, so for these, if we check the intensity, this is at the 100 mark. We can, if I draw a straight line from here, see, this is around 50 or it's around 52. Okay, from the options, I can see that this is basically 52. And this one would be a little less. So from the option, again, it is like 48. Okay, so yeah, you can check the other options too from here, 52, 48. Okay, 52, 48. So yeah. And the molecular masses here, this would be 158 and this would be 162. To find this relative molar mass, we will use our general formula, that is molar mass times intensity divided by the total intensity. So summation of m times I divided by summation of I. Okay, this will give us the relative molecular mass. Okay, so what happens here is 158 times 52 plus 160 times 100 plus we have 162 times 48. We can divide entirely by the total sum of I. Sum would be 52 plus 100 plus 48. So if we check the options, option A comes out as the correct answer. Now let's move on to the next question. So in this question, we have to identify which option represents a p orbital. Okay. So the first one, this is a double dumbbell shape, but the dumbbells are not equal in shape. So this is a hybridized p orbital. Okay. P orbital. Option B, it's a spherical shape. So we know that s orbital has a spherical shape. So option B is the s orbital. Option C is a dumbbell-shaped orbital in which both of the dumbbells have the same size. So option C is actually the p orbital. So yeah, option C is the correct answer to this question. Moving on to question 6. In this question, the diagram shows the first ionization energies of consecutive elements in the same period of the periodic table. So all these elements are in the same periodic table. Okay, I mean in the same period. Okay, so which factor explains why element X has a higher ionization energy as compared to element Y? Okay, let's start with the last option. Element Y has a greater nuclear charge. If element Y has a greater nuclear charge, obviously its ionization energy should be higher than that of X because the nucleus will try to pull the electrons towards itself with a greater force. So we would require much more energy to remove the outermost electron. So this option, it won't be correct. Okay. Second one, element X has a full octet. This is again not correct because in the same period, only the noble gases can have a full octet. So element X cannot possibly have a full octet. Option B, element Y has a smaller atomic radius. Okay, now there is again a problem with this option. If element Y has a smaller atomic radius, then obviously the electrons, they are much closer to that of the nucleus. As a result, we would require more energy to remove the electrons. So the ionization energy of Y should be higher than that of X if we go by this logic. So again, this is not correct. So we are left with option A, and that is exactly our correct answer. What happens here is, even if we check the second period, X, if you write the electronic configuration of X would be, like I can say it would be NS2. Okay, but the electronic configuration of Y would be NS2, NP1. Okay, so there would be 2 electrons in the s orbital and 1 electron in the p subshell. Okay, now removing the electron from p subshell would be much easier than removing a paired electron from the s subshell. That's the reason we require less energy to remove the electron from Y, and as a result, Y has a lesser ionization energy as compared to X. Moving on to question 7. In this question, we have to find out which species has the same electronic configuration as that of argon. Now, to solve this question, we do not actually have to write the electronic configuration for all of these species. What we can do is we can just see which of these species has the same number of electrons as that of argon. To solve this, we can use the periodic table that will be attached with your question paper. Okay, so to solve this, firstly identify argon. Here is our argon. Okay, now check the electrons on the ions. Okay, for Br minus, Br normally has 35 electrons, and negative means it has 1 extra electron. So 36 is the total number of electrons in Br minus, which is not equal to 18. So this is not the correct option. Ca2 plus. Calcium generally has 20 electrons, but in Ca2 plus it loses 2 electrons. So it has a total of 18 electrons, which is equal to the total number of electrons in argon. So B is the correct answer. But let's check the options for the other. Let's check the answer for the other options. Al has 13 electrons generally, but Al3 plus has 10 electrons. Okay, so this is again not the correct answer. Si4 plus, Si generally has 14 electrons, but it loses 4 electrons, so it has 10 electrons. So this is also not the answer. So option B is the correct answer. Now moving on to question 8, which trend is correct going down group 1? Now let's try to solve it randomly. When we go down a group, what happens is the number of shells in which electrons are held increases. Okay, so for example, group 1 hydrogen, this has only one shell. Here you have 2 shells for lithium, sodium you have 3, potassium 4, rubidium 5, cesium 6, and francium 7. So what happens is, as these number of shells increases, the distance between the outermost electron and the nucleus increases. Okay, as a result, what happens is the net attractive force, it also decreases. Also, there are forces of repulsion too. So we can say that the ionization energy, or the first ionization energy, decreases as we go down the groups. Okay, so C cannot be the correct option. Okay, as ionization energy decreases, our reactivity increases. Okay, that's the rule. So option B, it also goes away. Now, as we go down the group, what happens is the sizes of the atoms increases. Okay, as the size of the atoms increase, what happens is the van der Waals force, it decreases. Okay, so if the van der Waals force decreases, what happens is the melting point and the boiling point will decrease. So option A is also incorrect. So we can say option D is the correct answer. Like, obviously, even from if you studied the periodic properties, we know that electronegativity decreases as we go down the groups. Okay, so this is all about question number 8. Let's move on to question 9. In question 9, we have to find the overall charge on this chromium 3 complex. Chromium 3 means chromium has a +3 charge. Okay, and we have 4 hydrogen ligands attached to it. Now we know charge on hydrogen ligands will be 0 because H2 is a neutral ligand, and there is Cl2. Cl2 will have a -1 charge. Okay, this will be equal to X. So upon solving this, we get X as +1. Okay, or you can also say 1 plus. So B is the correct option to this question. Okay, now let's move to question 10. We have the following compound contains both ionic and covalent bonds. Okay, let's do an option-wise analysis. In MgO, it is completely ionic because you have Mg2 plus and O2 minus. There is an ionic bond, so A is not the correct answer. Next one, CH2Cl2. You see all of the bonds here are covalent bonds, so this is also not the correct answer. Third one, CH3COOH. This again has all the bonds as covalent bonds. Okay, so this is not the answer. Now NaOH is only left, and this is the correct answer. This is because NaOH is Na plus and OH minus. Okay, you see there is an ionic bond here and there is a covalent bond here. So option D contains both ionic and covalent bonds. Okay, moving on to question 11. In this question, we have to find out which substance is most likely to be ionic. Okay, now for ionic compounds, our melting and boiling points are always high. So we can just rule out option B and D. These won't be correct. Also, ionic compounds are only soluble in polar solvents. For example, water, which is a polar solvent. Hexane is a non-polar solvent. So ionic compounds won't be soluble in hexane. In both the option, we see that it's low. No problem. Another thing is electrical conductivity of a solid. Now, ionic compounds do not conduct electricity in solid. It conducts electricity only in its aqueous state. Okay, like only when you dissolve the ionic compound in water. Because when in the solid form, the ions cannot move. Okay, so that's why they cannot conduct electricity. So option A also goes. So option D is the correct answer. So the melting point of ionic compounds are high. They are not soluble in hexane, and electrical conductivity in solid state is low for ionic compounds. Moving on to question 12, which contains delocalized electrons. Delocalized electron means like condition in which the electrons can move. Let's see all of the options one by one. So in this case, to identify the delocalized electron, just check if this electron is in a closed vicinity of a double bond. Okay, so what happens here is this electron can go here and this double bond can come here as an electron. Okay, so see, you can find a sort of a movement in these electrons. Okay, so option 1, it's correct. Electrons are delocalized. In the second one, we have CH3, COO minus. Okay, COO minus will have 3 lone pairs. Now what happens again, see there is a double bond in the close vicinity of this lone pair. So lone pair can come here, double bond can go here. So yeah, I can draw the structure in this way. Okay, second one is also correct. The electrons are delocalized. For the third one, the structure looks like this. So even here, the electrons are delocalized because you can check here, there can be a movement of these electrons with these double bonds. So option D is the correct answer. 1, 2, 3, all of them have delocalized electrons. And the next one, which series are all carbon atoms are sp2 hybridized? So how to identify sp2, sp3 and sp hybridized? So if there are 4, firstly, a single bond contains one sigma bond. A double bond contains one sigma bond and one pi bond. And one triple bond contains one sigma and two pi bonds. Okay. Now, if around the carbon atom, if you have two sigma bonds, then the carbon is sp hybridized. If you have three sigma bonds, then the carbon is sp2 hybridized. And if you have four sigma bonds, then the carbon is sp3 hybridized. Okay. Now we have to check the options. First option we have C2H2. C2H2 is this. Now one sigma bond is in the triple bond and one sigma bond is in this single bond. So this one is sp hybridized. This one is sp hybridized. So as this one is sp hybridized, this option is correct because all of the atoms should be sp2 hybridized. In the next one, also there is also another C2H2 here. So this one will also go away. We have C2H4. Okay, C2H4 is this. Now let's check any one of the carbon atoms. So this double bond will contain one sigma bond, this carbon hydrogen bond one sigma bond, and this will also contain one sigma bond. So you see there are three sigma bonds around this carbon atom. So I can just say this is sp2 hybridized. Similarly for this carbon atom, you can see three sigma bonds around this carbon atom. So this is also sp2. So C2H4, this is sp2. Okay, first option gets correct. The next one, H2CO. Okay, now check the carbon atom. There is one sigma bond, here is one sigma bond, and here is one sigma bond. So there are three sigma bonds. Again, this is sp2. This one also looks correct. Now the last one, HCOOH. Again, here is one sigma bond, here is one sigma bond, and here is one sigma bond. So this is sp2. Okay, this is also correct. So option B is the correct answer. So we can just try out the last option to C2H6. You see there are four sigma bonds around each of the carbon atoms. This is sigma, this is sigma, this is sigma, this is sigma. So this is sp3 hybridized. So yeah, option B will be the correct answer to this question. Now moving on to question 4. We have to calculate the enthalpy change when 5 grams of water is heated from 10 degrees to 18 degrees Celsius. Okay, so what we need to do is we need to change the unit of the specific heat capacity. So the specific heat capacity is 4.18 kilojoule per kg Kelvin. Okay. Now we know that 1 kilojoule is basically 1000 joules. Okay, so specific heat capacity, I can denote it with C. So I can write 1 kilojoule as 1000 joules, and also I can write 1 kg as 1000 grams. And let's keep this Kelvin as it is. Okay, so this becomes 4.18 joule per gram Kelvin. This C. Now enthalpy change would be mass into specific heat times temperature difference. Okay, so mass is 5 grams. Okay, C would be 4.18 joule per gram Kelvin. Okay, and for delta T, see this is in degree Celsius. I need to convert it to Kelvin to to get the units out. Okay, so 273 plus 18 minus 273 plus 10. So what happens here is when you do the subtraction, these two go away, and so this becomes 8, and this unit is Kelvin. Now doing the unit analysis, I can just cancel out these 2 grams and these 2 kelvins. So final answer is 5 times 4.18 times 8 joules. So whenever you have a temperature difference, the temperature difference in degrees Celsius will also be equal to the temperature difference in kelvins. Okay, so you can also directly apply that, and that will also be correct. So for question number 14, option A is the correct answer. Moving on to question number 15. In this question, we can directly apply the formula. Okay, so what happens is the enthalpy of a reaction is enthalpy of combustion of reactants minus enthalpy of combustion of products. So enthalpy of combustion of reactants is like, enthalpy of combustion of O2 will be 0. Okay, so we have graphite and CO only. So for graphite, that's they're in the reactants, so 2 times minus 394 minus of 2 times 283. 2 times minus 283, sorry. So yeah, I can just rewrite it like this. And option D becomes our correct answer to this question. Moving on to question 16. So this table shows us a variation of standard gas free energy with temperature for a reversible reaction. Okay, so you see, as you're increasing the temperature, delta G becomes more negative. Delta G becomes more negative means the reaction is becoming more spontaneous. Reaction becoming more spontaneous means you are getting more products. More of the reactants are getting converted to products. The reactant is getting favored on the product side. Okay, using this information, we can remove some options. Okay, as you're increasing the temperature, you know that the reaction is shifting towards the product side. So equilibrium, it does not shift to the left; it shifts to the right. Okay, Kc decreases as temperature increases. This is also wrong. Okay, Kc should increase using the same logic. Forward reaction is more spontaneous below 300 Kelvin. That is wrong. Below 300 Kelvin, delta G is positive. Whenever delta G is positive, this means that the reverse reaction is more spontaneous. So this is also incorrect. So from option elimination, option C should be correct answer. So how to get the answer in reality? See, delta G is delta H minus T delta S. Okay. As you're increasing the temperature, delta G becomes more negative. Okay. So what happens is this term, the magnitude of this term increases. So we can also say that delta S is positive for this case because delta H is constant, delta H and delta S, both of them are constants. Okay. Now we need to know the sign of this delta S. Okay. Now see, as increasing the magnitude of T makes G more negative, we can see that delta S is positive. Delta S positive means entropy is higher in products as compared to reactants because delta S is S of products minus S of reactants. So from this, option C is the correct option, correct answer to this question. Now question 17. Which substance has the highest lattice enthalpy? So for this, generally I use a technique. There is this formula from electrostatics, that's of physics, okay? So we can actually get the lattice enthalpy values from this formula. Q positive is the charge of the cation and Q negative is the charge of the anion. So if you have more charge on the cation or anion, then the lattice, this is the lattice enthalpy. So if you have more charge on the cation or anion, the lattice enthalpy will be more. In all the cases, anions have a charge of -1. Cl minus, F minus, both are -1. But cations, for K, it is +1 and for C is +2. So I want more charge on my cations. So I can eliminate option A and option C. And my answer will somewhere be option B or option D. Okay, this is from the charge. Now from this R. R means smaller the radii of the cation or the anion, greater will be the lattice enthalpy. Between Cl and F, I know that F has a smaller radii. Okay. So option D will be the correct answer. CAF will have the highest lattice enthalpy values between all these four options. Now moving on to question number 18. And this question is a little problematic one. Okay, it's actually very hard, and I personally believe none of the options is correct. But still, we can figure out how option B is the correct answer as it is given in the answer sheet or in the mark scheme. Okay, so it says that the curve 1 shows how the mass change when marble chips are added to excess HCl. So what's the reaction HCl plus marble chips is calcium carbonate. So we have the products as CaCl2 and we have CO2. Okay, now we see the HCl is on excess. Okay, so marble chips are always the limiting reagent. So even if we double the volume or even if we double the acid concentration, it won't make any effect because HCl is already in excess. So C and D, these options won't be correct. Another thing is, it's also in the course that this reaction, when we study this reaction, we know that this is an exothermic reaction. So heat is released for this reaction. Okay, if you heat a reaction in which heat is released, the reaction goes backwards. Okay, in this case, as it's an irreversible reaction, this reaction won't go that fast. Okay, not that much amount of CO2 will be produced. So I can, with this reasoning, I can also eliminate option A because here you see there is more of reaction in this dotted line. As curve 2 is much lower than curve 1, you see that much more CO2 is evolved in curve 2. So we are just left with option B, which is the correct answer, as given in your mark scheme. Now moving on to question number 19. On the following, which letter represents activation energy? Okay, now this is literally one of the easiest questions. See, A and D are marked on the probability axis, so these two won't be the answers, obviously. So only B is marked on the energy axis, and C, if you guys have checked the Maxwell-Boltzmann curve at least once, you know that this is C will represent the number of molecules having energy, having the required energy for reaction. So obviously C is the only one that's in the energy axis. I mean, B is the only one that's on the energy axis. So B should be the correct answer in this case. And it is. On question number 20, there's also a little problem with this question. Thing is, they forgot to mention which one is the slow one and which one is the fast process. Okay, so from the options, or we can say that step 1 is basically the slow step. Okay, and from the slower step, we can write the rate equation. So from the slower step, rate is K is A square, because you know the slowest step basically is the rate determining step. So option C will be the correct answer for question 20. For 21, which of the graphs show a first order reaction? Okay, so we have concentration time and we have rate concentration. So we know this, that rate for a first order reaction, rate is directly proportional to the concentration. So rate is like K times concentration, which is a straight line passing through the origin. So Y is correct. Okay. Now we have to check between V and W. Also for a first order reaction, we know this, that concentration, that this reaction holds, this expression holds true. So this is a negative exponential equation. And with this, you can see V is the correct option. So V and Y, option B is the correct answer to this question. Moving on to question 22. Which changes produce the greatest increase in the percentage conversion of methane? Percentage conversion of methane means we want the forward direction to be favored. We want more of CO and H2 to be formed. We want CH4 to be converted, more and more converted. Okay. Now for pressure from La-Chatelier principle, we know that if we increase the pressure, the reaction shifts to the side having a lesser number of gaseous moles. Okay, so if we increase the pressure, if we double the pressure, the reaction will go to the reactant side, because on the reactant side you have 2 gaseous moles, on the product side you have 4 gaseous moles. Okay, so doubling won't work. If we halve the pressure, what happens is the reaction shifts to the side having a greater number of gaseous moles. So option B and D, these will go away. So either way, we have to check option C and D. Now for the H2O, if we have more of the reactants, obviously we will have more of the products. So if we double the proportion of H2O, obviously we will get more products. And it is what it is. So option C becomes the correct answer directly. Coming to question 23. In this case, see, all of them are gaseous, so we can assume that everything is happening in a 1 liter vessel. Okay, so to find Kc would be concentration of SO3 whole square by concentration of SO2 whole square and concentration of O2. So we know that 1 mole each is present at equilibrium. So Kc will be equal to 1, because 1 square by 1 square times 1, this is 1. Now Kc is 1, and we know that the temperature is constant. So Kc won't change. Okay, Kc will literally be 1. So I can say that SO3 square would be SO2 square times O2. Just from this equation, put Kc as 1. Now, we have to see in which case most, we will get the most amount of SO3. Okay, at equilibrium, we have to check it at the equilibrium conditions only. So yeah, for option A, the value of SO3 square would be 0.8 whole square times 1.2. Okay, option B, this will be equal to 0.9 whole square times 1.1. C would be 1.1 whole square times 0.9, and option D would be 1.2 whole square times 0.8. Now, even as calculators won't be allowed, we can use some mathematical tricks. For these two options, we can just say as 0.8 and 0.9 whole square. So these will be less than 1. And these values will be greater than 1. Okay. And obviously, we can just, from normal calculations, so we can feel that this one will have a greater value than this one. Okay, because it's 1.2 whole square. So obviously option D will become the correct answer. You can also work these multiplications out. 1.2 whole square would be 1.44 times 0.8. Okay, and then again for 1.1 whole square 2. Okay, so now we are done with question. Moving on to question 24, we have to find out which of the following options is amphiprotic. Now, some students directly could choose option B because H2O, it is the only amphiprotic a species in the following options, where it's studied widely in the acid-base chapter. There's another way of doing it, that is try reacting all of these compounds firstly with an acid and then with a base. Okay, you will see NH4 plus can only react with a base. It can only donate an H plus ion, but it cannot react with an acid. Similarly, for H3O plus, it can only react with an H plus, and PO4 3 minus can only accept an H plus ion. Okay, so it cannot exactly react with the base. So obviously option C becomes the correct answer to this question. On question 25, which solution has a pH of 9? Now, whenever you have an acid, okay, that is HCl, the pH will always be less than 7 for an acid. Okay, here you have 10 to the power minus 9 mole per dm cube of HCl aqueous. So this means like the total H plus concentration will be 10 to the power minus 7 plus 10 to the power minus 9. This 10 to the power minus 7 comes from water. In water, you have 10 to the power minus 7 concentration of H plus and 10 to the power minus 7 concentration of OH minus. And here you can say directly, you can say that the pH is minus of log 10 to the power minus 5. This is 5. Okay, so option A and option D cannot be the answers. So for option B, POH is minus of log OH minus. Okay, OH minus concentration is 10 to the power minus 5 because KOH is a strong base. So 10 to the power minus 5. So POH becomes 5. So we know that to convert POH to pH, we have to do 14 minus POH. So pH becomes 14 minus 5, that is 9. So option B becomes the correct answer to this question. Let's move on to question 26. Here we have to find out which is a Lewis acid and not a Brownstein-Lowry acid. Okay, Brownstein-Lowry acid is like the H plus, which acids which can donate H plus, bases which can accept an H plus. Okay, so firstly, NS3 it's a base. Okay, not an acid. So C will not be an answer. Cl minus is a neutral salt. Okay, or you can say it's a neutral ion. So this will not be the answer too. H3O plus it can donate an H plus. Okay, so this is a Brownstein-Lowry acid. Only BF3 can be our answer, and that is also true. This is because B has an empty orbital which it can use to accept electrons. So we know acids are electron acceptors, so BF3 is our correct answer. Moving on to question number 27, which combination will produce an alkaline buffer? Remember, for an alkaline buffer, you have to have a weak base plus salt of weak base. Using just this logic, I can eliminate option C and option D. But checking option A, the total H plus concentration for option A is 0. Moles of H plus ions is 0.05 times 2, that is 0.1. Okay. Now, problem is the acid concentration will be equal to the base concentration. As a result, this reaction, there won't be any NS3 left in this solution. So option A also cannot be our answer. The only viable answer is option B. In option B, moles of H plus would be 0.1 times 2, that is 0.2. So moles of NS3 left would be 0.5 minus 0.2, this is 0.3. And we can also find the moles of salt. Okay. Moving on to question 27, which combination will produce an alkaline buffer in water? So to produce an alkaline buffer, we need a weak base plus a salt of this weak base. Okay, so using just this concept, we can eliminate option C and D because it has a weak acid. Okay, now if you check option A, what happens is moles of base is 0.1 and moles of H plus, or you can say the moles of acid, is 0.05 times 2, that is 0.1. So this reaction will proceed towards completion. It will be a complete neutralization reaction. So option A won't be the answer too. So we are left with option B, and yes, that is the correct answer. In this case, what happens is after the reaction, you will have some amount of NH3 left and some amount of salt left, which will help produce the alkaline buffer. Now coming to question 8, we are given these 4 salt solution W, X, Y, Z, and we have these 2 metals W and X. And using this information, okay, like reaction of this W and X with these solutions, we have to find which of these 4 metals is most reactive. Okay, so between X and W2 plus, we see that there is a reaction. Okay, but between W and X2 plus, there is no reaction. So obviously X is much stronger than W. Okay, now between X and Y2 plus, there is a reaction. Okay, but there is no reaction between W and Y2 plus. Okay, so this means that X is stronger than Y. Okay, and W is obviously weaker than Y. For Z2 plus, we see there is no reaction for X and there is no reaction for Y. So we can say that the Z, it is the most reactive. So option D is our correct answer. Now on 29, we have to identify which species gets reduced and which one is the reducing agent. This is again very easy. We just have to write the oxidation numbers and that will be okay. For I minus, oxidation number is -1 here. In I2, the oxidation number is 0. So there is a decrease in oxidation. There's an increase in oxidation number. So this is an oxidizing process. The species which gets oxidized is called the reducing agent. So I minus is our reducing agent. So it can be either option A or the option D. In MnO2, the oxidation number of Mn is +4. Okay, because X plus of twice of -2 equals 0. So X becomes +4. And here the oxidation number is +2. So MnO2 is getting reduced. Okay, so H plus is not getting reduced because H has +1 oxidation state here and also +1 in H2O. So B, C, D, these are wrong. Option A is our correct answer to question 29. Now for question 20, we have to find the cell potential of the spontaneous reaction. Okay, so just a tip, for a spontaneous reaction, your E0 value should be positive. Okay, using this information, just writing here for spontaneous, E0 should be positive. So I can just eliminate option A and option C, left with option B and option D. So the most viable, the most effective cell potential will be the one which has the highest E0 value. And we can get this by reversing the first reaction and adding it with the second one. Okay, so what happens when we get Mn? E naught will be plus 1.18, and we have twice Ag plus twice electron, giving you twice Ag. E naught will be 0.8. Now adding these two up, we have twice Ag plus Mn, giving you twice Ag plus Mn2 plus. So the E naught value will be the sum of these two, 1.18 plus 0.8. So 1 plus 1.98. So this will be our reaction. This will be the E naught value. Option D will be the correct answer. So that's all about question number 30. Moving on to 31. In this case, we have aqueous copper to chloride, and this is a very concentrated copper to chloride, which is electrolyzed using platinum electrodes. Okay. So let's say this is the anode. This is the anode. This is positive. This is the cathode. This is negative. Okay. So what are the ions here? You have Cu2 plus ions and Cl minus ions mainly, because it's a concentrated solution. Okay. There will be some H plus, there will be some oxygen, but we will neglect it because it's certain concentration. So obviously Cl minus will be attracted to the positive anode, and Cu2 plus will be attracted to the cathode. So finally at the cathode you will have Cu solid, and at the anode you will have Cl2 gas. So cathode is CO2, Cu, and anode is Cl2. So for 31, option C should be the correct answer. Moving on to question 32, which series is in order of increasing boiling point? So here we have one alcohol, one ketone, and one alkene. So obviously we know that in alcohols there is hydrogen bonding. Okay, so alcohols can have intermolecular hydrogen bonding, H bonding. So if you have intermolecular H bonding, so what happens is alcohol can create a network type thing. Okay, so when we try to boil it, it requires a lot of extra energy to break these intermolecular bonds. So alcohols will have the highest boiling point as compared to ketones or alkenes. So with just this knowledge, we can say option B is the correct answer. Okay, and between alkenes and ketones are a little polar and alkenes are non-polar. Okay, and we know polar molecules have a higher boiling point as compared to non-polar ones. So option B will be the correct answer to 32. In question number 33, we have to write the IUPAC name of the compound. So the first step is identifying the largest chain. So the largest chain will be like this chain. Now it's time to number. So we can do the numbering from the bottom side, because that will contain the groups and the double bond at the lowest locants. So 3, 4, 5, 6. So 6 means it's hex. And at the 2 position you have ene, so hex 2 ene. And at the 4 position you have methyl. So name would be 4 methyl hex 2 ene. So that corresponds to option A. In question 34, what is found in a propagation step of the substitution reaction between bromine and ethane? So what basically happens is first the initiation step, in which bromine molecule, or I mean this thing, there is this homolytic fission in which both these electrons come out and we have this bromine radical. The second step is the propagation step, in which what happens is, I can draw it in this way maybe. Bromine will snatch away this hydrogen, and this bond will also break in a homolytic fashion. Okay, so this radical is formed in the homolytic fission. So I can see option A is the correct answer here. Question number 36, which is most likely to hydrolyze via SN1 mechanism? We need a 3-degree carbon. So in the first one is not, the first one is basically this, Br. Okay, not just a 2-degree carbon. Second one is CBr. Again, this is a 2-degree carbon, but the third one is a 3-degree carbon. Okay, this is 3 degree. And the last one is a 1-degree carbon. So obviously option C is the correct answer to this question. Now, reaction of benzene with concentrated nitric acid and sulfuric acid is always nitrobenzene. We can directly put option C. Okay, so what happens is, this is the reaction. Conc HNO3, Conc H2SO4, and NO2 group gets substituted to this benzene ring. And option C becomes the correct answer. Question number 37, how many chiral centers are there in the following molecule? Chiral center means all the 4 groups attached to this carbon should be different. Here you have one CH, 2OH, 1 H. This group, if you check via here, this one and this part, these two are different. So this is a chiral center. The next one is this one. This one have OH here, this one has H here. If you check these two parts, this one and this part, they are different. Okay, so this carbon is also chiral. Coming to this one, OH, H divided by the center. This part and this part, they are completely different. So yeah, this is also chiral. Last is this carbon atom here. Again, CH2OH and OH. If you check via this pathway and this pathway, both of them are different. So this is also chiral. This carbon isn't chiral because it has 2 hydrogens attached to it. Same for this carbon, it has 2 hydrogens attached to it. So we have total of 4 chiral centers. This one, this one, this one, and this one. So option C is the correct answer to this question. Question number 38. Enthalpy of combustion of a fuel was determined using the calorimeter shown. The final result was lower than the literature value. So what can be the options? There are 3 factors that is given here. Not all heat of combustion was transferred to the calorimeter. Yes, that can be an option. That can be a correct answer because lesser heat means obviously the enthalpy recorded will be lower. Incomplete combustion occurred. Yes, that is also a very likely scenario. So yeah. The third one is the temperature probe touches the bottom of the calorimeter. This cannot be correct because if it touches the bottom of the calorimeter, the temperature should give you a higher value. Okay, because this copper is directly, the flame is directly touching this copper plate. So there would be a direct conduction. So the temperature recorded should be greater as a result. If it touches the bottom of the calorimeter, the enthalpy that has been determined should be higher than the literature value. So this cannot be correct. So option 1 and 2 only are correct. So A is the correct answer to this question. So moving on to question 39. In this question, we have to find the mean titer value. So if you check the butyrate readings, it's given plus 0.05 centimeter cube. So in one reading of this butyrate, you have an uncertainty of 0.05 centimeter cube. In every trial, we have to take the butyrate reading twice, one for the initial, one for the final. So the butyrate, the uncertainty for each of these titers is 0.1 centimeter cube. So option A or D, any one of them would be correct. Now we just have to find the mean titer value. This will be 11.15, this will be 11.1, this will be 11.2, mean will be 11.15 plus 11.1 plus 11.2 divided by 3, which comes out as 11.15. If we round off this figure, what we will get is 11.2 by the basic laws of significant figures. So option D will become our correct answer to this question. Moving on to question number 40. To solve this, we have to use the chemical shift of this H1 NMR, which is given in your IB data booklet. So yeah, so we have 4 options: propane, propanol, propanol, and dimethyl propane. Okay, so if we check the shifts here, one shift is at 1 or less than 1, another one is at less than 1.5. Okay, we see that any shift that contains oxygen starts from 2. So we can remove option B and C. Now let's check for propane. In propane, CS3. So you have basically 2 types of hydrogen. So 2 peaks can be expected. So one of them is the CS3 peak, and yeah, that we can find here. Another one is this. One second. This is this CH2R peak. Okay, which can be found basically here. Okay, so with these 2, we can say option A is the correct option, correct answer to this question. And with this question, we come to the end of the solution of this question paper. I'll soon be posting the solutions of the SL question paper 2 as well as the time zone 2 question paper 2. Okay, so thank you so much for watching this video. See you guys again soon.